Okay, guys, welcome. Today we're going to talk about roots of a quadratic equation, and specifically we're going to talk about how we can identify what type of roots and how many of those roots we're going to have by using what's called the discriminant, right? Now, if you look at the quadratic formula, let me give myself a little bit of room here, right? You have this x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Right, now sort of the most complicated thing in this formula is the expression under the square root, right? Now, we talked about square roots extensively in the previous chapter, and if we look at b squared minus 4ac, you can see that depending on what that is, you're going to have a real number or you're going to have an imaginary number, right? Or you could even have, like 0 is obviously a real number, but if you use plus or minus 0, that's sort of a different scenario as well. So you can learn a great deal about the type of roots that you're going to have by just looking at whatever b squared minus 4ac is, because that's the expression that you would find under the square root, right? So if your b squared minus 4ac is less than 0, which means that you have a negative number, that's the scenario where you get two complex conjugate roots, right? Because you're going to get plus or minus something times I, right? And that means that you have the complex conjugate and the other number, right? Now, when b squared minus 4ac is equal to 0, right? Well, that means that you get a double root, because whatever your negative b over 2a is, that's what your root is, and then you're adding and subtracting 0 from it, so you're not changing that. So that's where you get that double root, right? And then if your expression underneath the radical is positive, you then sort of have two subsets, right? So if whatever under here is a perfect square, then you get two rational roots. If it's not a perfect square, then you get two irrational roots, right? So that's sort of the different breakdowns that you can have. Okay, so let's take a look at a couple of these, right? So without solving this, we're just going to talk about what type of the roots we're going to have just by using the discriminant. So in part A, we have 3x squared minus 4x plus 6 is equal to 0. Okay, now if we just want to figure out what the roots are going to do, we just need to find b squared minus 4ac. So in this case, we're going to have a negative 4 squared, because that's my b squared, minus 4 times a, which is 3, times c, which is 6. So we're going to get 16. And let's see, 4 times 3 would be a 12, and then times 6 would be a 72. So we're going to get 16 minus 72, right? Now, you could figure out what this is, right? If you do 16 minus 72, you're going to get that this is negative 56. All right, but most importantly, it's negative, right? So this means that we're going to have two complex conjugate roots. Right, and we didn't have to solve it just to figure that out, right? We're just figuring out what the roots are. Okay, now in part B, we have 2x squared minus 7x is equal to negative 1. Well, of course, the first thing that we need to do is we need to add 1 to both sides. So if we do that, we have 2x squared minus 7x plus 1 is equal to 0. So now we can find b squared minus 4ac, and we're going to get negative 7 squared minus 4 times a, which is 2, times c, which is 1. And we're going to get 49 minus 8, which is 41. Right? And of course, this is positive, so we're going to get two real roots. And of course, since 41 is not a perfect square, these are going to be irrational roots. Right, so you could include that in there. Okay, and then for part C, we have 4x squared plus 12x plus 9 is equal to 0. Okay, so again, we just want to find the discriminant. So we need to do b squared minus 4ac. So we have a 12 squared minus 4 times a, which is 4, times c, which is 9. So we get a 144. And then let's see, we get a 16 times 9, which I also believe is 144. All right, let me just double check that. You get a 4, 5. Yep, so we get a 144. So this is 0. So this means that we have the double root. Right, and it's a double real root, we should say. Okay, so that's how we can sort of examine what type of roots we're going to have just by using the discriminant. Okay, now of course, if you were to look at ax squared plus bx plus c is equal to 0, you're really finding the x-intercepts of the equation ax squared plus bx plus c is equal to y, right? So as soon as you set y equal to 0 and solve for x, right, you're finding the x-intercepts. Right, so you can use the discriminant to quickly tell you how many x-intercepts you're going to have. If you have 2 real ones, it's going to touch the x-axis 2 times. If you have a double root, it's going to touch 1 time. And if you have 2 complex roots, it's not going to touch. Right, you're not going to see it. Right, so that's sort of what this is sort of what I just sort of said. Right, if it's positive, you're going to meet the x-axis at 2 distinct points. If it's 0, you're going to meet it at 1 point, and then if it's negative, you're not going to meet the x-axis. Okay, so that concludes this video on looking at the discriminant for quadratic equations. I hope you enjoyed, and I will see you next time.